All right, team, in this lesson, let's learn how to make a prediction. This goes in that prediction part of your lab write-ups. So when you make a prediction or a hypothesis, I want you to anticipate what your data will look like. So we're anticipating what our graph's going to look like. And let's use a scientific question for an example. So our example is, how does the air density affect the max velocity of an aircraft? So our independent variable, we're going to change the air density of the atmosphere somehow, and then we're going to measure the max velocity of our plane, of our aircraft. Good. So the first step is to draw and label the axis for our something that I called the prediction graph. So here's our prediction graph. Here's our y-axis where the dependent variable goes, and here's our x-axis where the independent variable goes. And make sure to label it. So on the x-axis, we have air density, and air density is density. It's measured. Density is like grams per milliliter. It's a mass per unit volume. So you'll learn more about what units to pick. Max velocity. Velocity, we often use miles per hour, kilometers per hour, but let's just use meters per second. That's a physics teacher's favorite. Good. Okay, so we have our labeled axes. And then the next thing is we just want to recall or remember the three basic relationships. Remember, there's just, try to remember right now. Can you remember them? Yeah, the three basic ones: direct relationship, an inverse relationship, and no relationship. So which one do you think this one is? Just recall that a direct relationship is whenever we have that positive slope as whatever variable on the x-axis increases, the variable on the y-axis also increases. Inverse is just the opposite of that. We have that negative slope. As the variable on the x-axis increases, we see a decreasing variable or value for the variable that's on the y-axis, and you see the rise overrun. The rise is negative. It's going down as you read the graph from left to right. And then a no relationship, it doesn't matter how much you change the value of the variable on the x-axis. You can increase it and then increase it again. The y value will stay the same. So kind of and then you'll have a slope. The slope of those equals 0. Okay, so what do we predict for this graph? Well, okay, so if you increase the density, if the air becomes very thick, I think that's going to slow the plane down. So I'm going to have a negative trend. And that, I just chose a inverse relationship. Cool. And so all I got to do is write a sentence that begins with I predict. So here's this right here, I call the prediction graph. And then I need a prediction statement. I predict that there will be an inverse relationship between air density and max velocity. And you don't need to tell me why for this, just the prediction graph and the prediction statement. So awesome. 1, 2, and that's good. That's all you need. So screenshot that and then put that in. You would screenshot your own and then you put that into the lab write-up. And just note that this comes before the experiment. So you don't need any values. This graph is just a prediction graph. It's not your actual data graph. So you don't need numbers, and you just need to show the trend or the pattern, otherwise known as the relationship. Show me a direct or an inverse or no relationship. That's it. Easy peasy lemon squeezy, right?